We already discussed first law of thermodynamics. If you look at first law of thermodynamics, right? We've seen first law of thermodynamics for a cyclic process and first law of thermodynamics for a non-cyclic process. We said for a cyclic process, I have that my Q minus W is equals to what? 0. Then for non-cyclic process, I have that Q minus W is equals to change in what? U. This is equation 2, right? What this means is that I'm applying equation 2 to all this type of process. We want to look at the types of thermodynamics process. We want to look at what the types of thermodynamic process. We have different types of thermodynamic process. This is the PV diagram for thermodynamic process. Meaning that if the question says that draw your thermodynamic process, draw the diagram for your thermodynamic process. What the question is saying is that draw this diagram. This is your pressure, this is your what? Volume. So what it means is that you are representing each type of process on this PV diagram. For the first type of process, this is the nature of your isochloric process. This is for your isobaric process. This is for your isothermal process. This is for your adiabatic process. Now, let's apply equation 2 for each processes. We want to see our first law of thermodynamics, meaning Q minus W equals to change in 2. We want to see it in what? Each process. We want to see it in isochloric, in isobaric, isothermal, and adiabatic. Now, take the first one, adiabatic. When we say adiabatic, heat transfer does not occur in the system. There is no heat transferred to the system. When we say there is no heat transferred to the system, meaning heat is not entering the system, neither heat is leaving the system. That is, Q is equal to what? 0. So from this first law of thermodynamics, we know that Q minus W is equal to what? Change in U. And we are not saying that for a thermodynamic process, no heat is transferred to the system, meaning no heat is entering the system, neither leaving the system. In this case, Q is equal to what? 0. So equation 1, anywhere you see Q, substitute 0. What do you have? 0 minus W is equal to change in U. Therefore, change in U is equal to what? Negative W. Call this equation 3. Call this equation 3. So what this means is that for your adiabatic process, this becomes your equation. And you got this equation from what? First law of thermodynamics. You got this equation from what? First law of thermodynamics. And what this equation is telling you that it is not transferred from the system nor to the what? Surroundings. Right? Now, take note. When a system, we've said that previously, when a system expands adiabatically, when a system expands, okay, before then, when your system expands by piston, your work is what? Positive. Now, we are now rephrasing it. We now said, when a system expands adiabatically, work done will what? Still positive. Work done will still be positive. Adiabatically. The difference is that instead of expand by piston, you are using expand adiabatically. When a system expands adiabatically, meaning your work done is positive, W is positive. Now, when go back to sign convention. Go back to sign convention. Number 2 sign convention is what? When a fluid pushing a piston outward, what's the work done? Positive. Expand. The word expand, right? Now apply that to this place too. When your system expand adiabatically, what will your work done be? Positive. Exactly. Positive. So vice versa, when it compress adiabatically, your work done will be what? Negative. So take down. Right. When a system expands adiabatically, work is positive. When a system expands adiabatically, work is positive. That is, and if your work is positive, what's happening? Is it the system that is doing work or the surrounding that is doing work? The system is doing work. The system is doing work on the surrounding. Yeah, that's correct. Work is done on the system by the surrounding. So right, for the adiabatic process, we said when your system expands adiabatically, expand adiabatically. Work is what? Positive. Work is positive. And if work is positive, it means work is done. And if work is positive, does it mean that work is done on the system or on the surrounding? Work is done on the surrounding. On the surroundings. Work is done on the surrounding by the system. By the system. Meaning that if your system expands adiabatically, meaning work is done on the surroundings by the system, so your work is positive. Now, number two, if your system compresses adiabatically, if it's compressed adiabatically, what will happen? Compress adiabatically. Work done is what? Negative. Now, if work done is negative, what the work is done on what? Is it the surrounding or the system? Meaning, if your work done is negative, meaning work is done on the system by the surroundings. I have isobaric process. Isobaric process is a process in which the pressure remains constant. Now, if the volume is from V1 to V2 and the pressure remains constant, the work done is given by this is isobaric. What isobaric is telling is that the pressure remains constant. You know, we have state 1, we have state 1, we have state 2. Meaning at state 1 and at state 2, the value of pressure is the same. Let's say at state 1, the value of pressure is 300 millimeter mercury, or you say 300 Newton per meter square. Similarly, at state 2, what will be the value of pressure? 300 millimeter mercury, or 300 Newton per meter square. So we are not saying if your pressure is constant, the volume is ranging from V1 to V2. What will be the formula for work done? Earlier, can you still remember the equation? Do you still remember the formula for work done that I said previously? I said work done is equals to P dV. Meaning, if you want to relate it to integral, it becomes work done is equals to integral V1 V2 P dV. And we also have work done for a polytropic process, meaning W is equals to P1 V1 minus P2 V2, all divided by N minus 1. Yeah, polytropic process. So in this case, we are now saying that if the pressure is constant, the formula for work done becomes P all into bracket V2 minus V1. Part 3, we have isobaric process. So for isobaric process, isobaric process is the type of process in which your volume is constant. Your volume is constant. Now, if your volume is constant, it means that your work done is equals to 0. Your work done is equals to what? 0. What does that mean? This is it. What is the formula for work done? Work done is equals to P is equals to what? P dV, which implies what? W equals to P open bracket V2 minus V1. We said volume is what? Constant. The value of volume at state 1 is equals to the value of volume at state 2. Now, say at state 1, volume is equals to 30 meter cube. Right? Say at state 2, volume is what? 30. Meaning at state 2 also, volume is what? 30 meter cube. Now, calculate the value of work done using this formula. W becomes what? P all into bracket 30. Meaning P times 0, which is equals to what? 0. Therefore, work done is equals to 0. go back to first law of thermodynamics. By formula, we have it to be Q minus W is equals to change in U. Substitute 0. It becomes what? Q minus 0 is equals to change in U. Therefore, Q is equals to change in U. Q is equals to change in U. For adiabatic process, we have our first law of thermodynamics to be what? Check. What do you have for adiabatic? Change in U is equals to minus W. For isothermic, what do you have? Q is equals to what? Change in U. And for the first one, when change in U is equals to minus W, what does it mean? Meaning it is equals to what? 0. There is no heat entry, neither leaving. Now for isothermic, work is equals to 0. How is this work equals to 0? By the time you substitute the two constant value of volume, you get 0. 0 multiplied by P, you still have 0. Therefore, W is equals to what? 0. Now, for the last one, let's look at what? Isothermal. By the word isothermal, what does it mean? When we say isothermal, temperature is constant. Isothermal process is a constant temperature process for an ideal gas. Isothermal process is a constant temperature process for an ideal gas. Under isothermal process, change in U is equals to 0. Change in U is equals to what? 0. Therefore, Q minus W, which is equals to change in U, it implies what? Q minus W equals to 0. Right?